All right, let's take a look. First thing is factor. Let's take a look at it. Now, look at that tough factorization, but let's write this down. When I say tough, the other two polynomials look tough to factor. This would be x plus 2, x plus 3. Again, as you're going along and you're studying, make sure you're at least, getting these milestones as you do it. I got to be honest with you, the next one looks a little bit creepy. And what I mean is it looks like it might be tough to do. So what I would do, you certainly use the rational root theorem, but before I say anything, I want to claim that I bet it has a factor in common with this first guy. So I'm going to just simply say the roots I'd probably test out on this guy here, the second one, is x equals minus 2, and I would also try minus 3 out. They're relatively simple to do. Now what I mean by that, you plug it in here and see if you get a 0. Let's try the minus 2. What would you get? You would get minus 8, and then you would get plus 38 minus 30. That's a bingo. It definitely has that factor. X plus 2, I mean. Let's try this one. A little more difficult though, isn't it? You get minus 27. And let's see, you get plus, right? That would be 30 and 27, 57. And minus 30. That's also 0. So I get another factor there. What's that going to be? X plus 3. Now someone says, I wonder what is left there. It's got to be a linear factor, by the way. So looking at it, I don't have to do any divisions. I can look at that for the most part. I know it's x times x times x is x cubed. And I need a 30. I'm at minus 30, so 2 times 3 is 6. This has to be minus 5. All right? Let's look at our k. And I'm seeing it. All right? What did I do? I used what was given in the first one to get the second one factored. All right? Now, certainly, I'm going to start to erase this business over here. Again, I'm just moving along. I got two down, 1 to go. And I'm looking at that last guy. And you know what? I'm going to try again. I'm going to try to use the rational root theorem because I really don't see it as being an easy problem. But if I use the rational root theorem, maybe. So I'm going to say x equals, I'm going to try, what's the simplest one I could try at this point? Probably minus 2. Let me see if that's going to work. What do you get? And again, we're trying it here. I want to see if I get a 0. You get minus 8. Then you're going to get minus 28. Then you're going to get minus 4. And then you can get plus 40. Does that give you a 0? Let's take a look at it. You see minus 36. Yeah, wow, it gives you 0. So what do I now know? I notice a factor of x plus 2 here. Let me get my eraser out. That's done. I'll have to check that again. Let me try the other one. What's the next easy one I could try? I could try minus 3, right? Let's put that down. What would you get? You get minus 27. Then you'd get, what? 63, right? And then you get minus 6. This does not look good. There's no way that's going to work. So I'm gonna say that's not good. Now someone says, well, why don't you just long divide? You could, not denying. You get a quadratic, a simple quadratic to do, but let's take a look. What's the other one I could try? I could try 5. And why is that? I see that factor right there. So the root would have to be 5. Let's put that down. 125 minus, let's see, 7 times 25 is 175, right? Plus 10 plus 40. Let's see, minus 50. It's more difficult, by the way. Plus 50. Yeah, this works. So what do I get? X minus 5. Now someone says, how do you get the other factor? It's got to be easy. I'll tell you why. It's linear. Because it's a cubic, right? So it's got to be x. And then I look at this. 2 times minus 5 is minus 10. So it'd have to be plus 4. I'm sorry, that's minus 10. It's plus 40, so it's going to be minus 4. Let's just make sure that's true. 2 times minus 5 is minus 10. Minus 10 times minus 4 is plus 40. We're bingo. And again, it's just, basically simply look at the first and last term. Now, someone says, you're going to multiply that out. No. That worked out beautifully. All right? So this is your first step in getting an LCM, is to just factor it. And we got it all factored. Then what do? You write the LCM down. What's the LCM? Well, I see the factor x plus 2. at most once in any one of the factorizations. I see the factor x plus 3 at most once in any one of those factorizations. I see the factor x minus 4 at most once in any one of those factorizations. And I see the factor x minus 5 at most once in any one of those factorizations. That's the LCM. Let's get our red pen out. X plus 2, x plus 3, x minus 4, x minus 5, x minus 5. All right? Thank you.